1926.960. Working on or near exposed energized parts, Subpart V. 1926.960. Application. This section applies to work on exposed live parts, or near enough to them to expose the employee to any hazard they present. 1926.960. B. General. 1926.960. B1. Qualified employees only. 1926.960. B1 I through 1926.960. B1 2. Only qualified employees may work on or with exposed energized lines or parts of equipment. 1926.960. B1 2. Only qualified employees may work in areas containing unguarded, uninsulated energized lines or parts of equipment operating at 50 volts or more. 1926.960. B2. Treat as energized. Electric lines and equipment shall be considered and treated as energized unless they have been de-energized in accordance with Section 1926.961. 1926.960. B3. At least 2 employees. 1926.960. B3 I. Except as provided in paragraph B3 2 of this section, at least 2 employees shall be present while any employees perform the following types of work. 1926.960. B3 I A through 1926.960. B3 I E. Installation, removal, or repair of lines energized at more than 600 volts. Installation, removal, or repair of de-energized lines if an employee is exposed to contact with other parts energized at more than 600 volts. Installation, removal, or repair of equipment such as transformers, capacitors, and regulators if an employee is exposed to contact with parts energized at more than 600 volts. Work involving the use of mechanical equipment other than insulated aerial lifts near parts energized at more than 600 volts, and other work that exposes an employee to electrical hazards greater than or equal to the electrical hazards posed by operations listed specifically in paragraphs B3 I A through B3 I D of this section. 1926.960. B3 2. Paragraph B3 I of this section does not apply to the following operations. 1926.960. B3 2 A through 1926.960. B3 2 C. Routine circuit switching, when the employer can demonstrate that conditions at the site allow safe performance of this work. Work performed with live-line tools when the position of the employee is such that he or she is neither within reach of, nor otherwise exposed to contact with, energized parts, and emergency repairs to the extent necessary to safeguard the general public. 1926.960. C. Live work. 1926.960. C1. Minimum approach distances. 1926.960. C1 I. The employer shall establish minimum approach distances no less than the distances computed by Table V2 for AC systems or Table V7 for DC systems. 1926.960. C1 2. No later than April 1, 2015. For voltages over 72.5 kV, the employer shall determine the maximum anticipated per unit transient overvoltage, phase to ground, through an engineering analysis or assume a maximum anticipated per unit transient overvoltage, phase to ground, in accordance with Table V8. When the employer uses portable protective gaps to control the maximum transient overvoltage, the value of the maximum anticipated per unit transient overvoltage, phase to ground, must provide for 5 standard deviations between the statistical spark overvoltage of the gap and the statistical withstand voltage corresponding to the electrical component of the minimum approach distance. The employer shall make any engineering analysis conducted to determine maximum anticipated per unit transient overvoltage available upon request to employees and to the Assistant Secretary or designee for examination and copying. Note to paragraph C1-2. See Appendix B to this subpart for information on how to calculate the maximum anticipated per unit transient overvoltage, phase to ground, when the employer uses portable protective gaps to reduce maximum transient overvoltages. 1926.960. C1-3. The employer shall ensure that no employee approaches or takes any conductive object closer to exposed energized parts than the employer's established minimum approach distance, unless 1926.960. C1-3A through 1926.960. C1-3C. the employee is insulated from the energized part, rubber insulating gloves or rubber insulating gloves and sleeves worn in accordance with paragraph C2 of this section constitutes insulation of the employee from the energized part upon which the employee is working, provided that the employee has control of the part in a manner sufficient to prevent exposure to uninsulated portions of the employee's body, or the energized part is insulated from the employee and from any other conductive object at a different potential, or the employee is insulated from any other exposed conductive object in accordance with the requirements for liveline bare handwork in Section 1926.964 c. 1926.960 c. 2, type of insulation. 1926.960 c. 2 when an employee uses rubber insulating gloves as insulation from energized parts, under paragraph C1(3)(a) of this section, the employer shall ensure that the employee also uses rubber insulating sleeves. However, an employee need not use rubber insulating sleeves if 1926.960 c2(i)(a) through 1926.960 c2(i)(b) exposed energized parts on which the employee is not working are insulated from the employee, and when installing insulation for purposes of paragraph C2(i)(a) of this section, the employee installs the insulation from a position that does not expose his or her upper arm to contact with other energized parts. 1926.960 c2(2) when an employee uses rubber insulating gloves or rubber insulating gloves and sleeves as insulation from energized parts, under paragraph C1(3)(a) of this section, the employer shall ensure that the employee 1926.960 c2(2)(a) through 1926.960 c2(2)(b) puts on the rubber insulating gloves and sleeves in a position where he or she cannot reach into the minimum approach distance established by the employer under paragraph C1 of this section, and does not remove the rubber insulating gloves and sleeves until he or she is in a position where he or she cannot reach into the minimum approach distance established by the employer under paragraph C1 of this section. 1926.960 d. Working position. 1926.960 d1. Working from below. The employer shall ensure that each employee, to the extent that other safety-related conditions at the worksite permit, works in a position from which a slip or shock will not bring the employee's body into contact with exposed, uninsulated parts energized at a potential different from the employee's. 1926.960 d2. Requirements for working without electrical protective equipment. When an employee performs work near exposed parts energized at more than 600 volts, but not more than 72.5 kilovolts, and is not wearing rubber insulating gloves, being protected by insulating equipment covering the energized parts, performing work using liveline tools, or performing liveline bare handwork under Section 1926.964 c, the employee shall work from a position where he or she cannot reach into the minimum approach distance established by the employer under paragraph C1 of this section. 1926.960 e. Making connections. The employer shall ensure that employees make connections as follows. 1926.960 e1. Connecting. In connecting de-energized equipment or lines to an energized circuit by means of a conducting wire or device, an employee shall first attach the wire to the de-energized part. 1926.960 e2. Disconnecting. When disconnecting equipment or lines from an energized circuit by means of a conducting wire or device, an employee shall remove the source end first, and 1926.960 e3. Loose conductors. When lines or equipment are connected to or disconnected from energized circuits, an employee shall keep loose conductors away from exposed energized parts. 1926.960 f. Conductive articles. When an employee performs work within reaching distance of exposed energized parts of equipment, the employer shall ensure that the employee removes or renders non-conductive all exposed conductive articles, such as keychains or watch chains, rings, or wristwatches or bands, unless such articles do not increase the hazards associated with contact with the energized parts. 1926.960 g. Protection from flames and electric arcs. 1926.960 g1. Hazard assessment. The employer shall assess the workplace to identify employees exposed to hazards from flames or from electric arcs. 1926.960 G2 Estimate of available heat energy. For each employee exposed to hazards from electric arcs, the employer shall make a reasonable estimate of the incident heat energy to which the employee would be exposed. Note 1 to paragraph G2 Appendix E to this subpart provides guidance on estimating available heat energy. The Occupational Safety and Health Administration will deem employers following the guidance in Appendix E to this subpart to be in compliance with paragraph G2 of this section. An employer may choose a method of calculating incident heat energy not included in Appendix E to this subpart if the chosen method reasonably predicts the incident energy to which the employee would be exposed. Note 2 to paragraph G2. This paragraph does not require the employer to estimate the incident heat energy exposure for every job task performed by each employee. The employer may make broad estimates that cover multiple system areas provided the employer uses reasonable assumptions about the energy exposure distribution throughout the system and provided the estimates represent the maximum employee exposure for those areas. For example, the employer could estimate the heat energy just outside a substation feeding a radial distribution system and use that estimate for all jobs performed on that radial system. 1926.960 G3 Prohibited clothing. The employer shall ensure that each employee who is exposed to hazards from flames or electric arcs does not wear clothing that could melt onto his or her skin or that could ignite and continue to burn when exposed to flames or the heat energy estimated under paragraph G2 of this section. Note to paragraph G3. This paragraph prohibits clothing made from acetate, nylon, polyester, rayon, and polypropylene either alone or in blends, unless the employer demonstrates that the fabric has been treated to withstand the conditions that may be encountered by the employee or that the employee wears the clothing in such a manner as to eliminate the hazard involved. 1926.960 G4 Flame-resistant clothing. The employer shall ensure that the outer layer of clothing worn by an employee, except for clothing not required to be arc-rated under paragraphs G5I through G5V of this section, is flame-resistant under any of the following conditions. 1926.960 G4I through 1926.960 G4 The employee is exposed to contact with energized circuit parts operating at more than 600 volts. An electric arc could ignite flammable material in the work area that, in turn, could ignite the employee's clothing. Molten metal or electric arcs from faulted conductors in the work area could ignite the employee's clothing. Or, note to paragraph G4.3. This paragraph does not apply to conductors that are capable of carrying, without failure, the maximum available fault current for the time the circuit protective devices take to interrupt the fault. The incident heat energy estimated under paragraph G2 of this section exceeds 2.0 calories per square centimeter. 1926.960 G5 Arc rating. The employer shall ensure that each employee exposed to hazards from electric arcs wears protective clothing and other protective equipment with an arc rating greater than or equal to the heat energy estimated under paragraph G2 of this section whenever that estimate exceeds 2.0 calories per square centimeter. This protective equipment shall cover the employee's entire body, except as follows. 1926.960 G5I through 1926.960 G5V. Arc-rated protection is not necessary for the employee's hands when the employee is wearing rubber insulating gloves with protectors or, if the estimated incident energy is no more than 14 calories per square centimeter, heavy-duty leather work gloves with a weight of at least 407 gm/m2, 12 Us/YD2. 1926.960 G5.2. Arc-rated protection is not necessary for the employee's feet when the employee is wearing heavy-duty work shoes or boots. Arc-rated protection is not necessary for the employee's head when the employee is wearing head protection meeting section 1926.100 B2 if the estimated incident energy is less than 9 calories per square centimeter for exposures involving single-phase arcs in open air or 5 calories per square centimeter for other exposures. The protection for the employee's head may consist of head protection meeting section 1926.100 B2 and a face shield with a minimum arc rating of 8 calories per square centimeter if the estimated incident energy exposure is less than 13 calories per square centimeter for exposures involving single-phase arcs in open air or 9 calories per square centimeter for other exposures, and for exposures involving single-phase arcs in open air, the arc rating for the employee's head and face protection may be 4 calories per square centimeter less than the estimated incident energy. Note to paragraph G. See Appendix E to this subpart for further information on the selection of appropriate protection. 1926.960 G. 6. Dates. 1926.960 G. 6. I. through 1926.960 G. 6. 3. The obligation in paragraph G. 2 of this section for the employer to make reasonable estimates of incident energy commences January 1, 2015. The obligation in paragraph G. 4 of this section for the employer to ensure that the outer layer of clothing worn by an employee is flame resistant when the estimated incident heat energy exceeds 2.0 calories per square centimeter commences April 1, 2015. The obligation in paragraph G. 5 of this section for the employer to ensure that each employee exposed to hazards from electric arcs wears the required arc-rated protective equipment commences April 1, 2015. 1926.960 H. Fuse handling. When an employee must install or remove fuses with one or both terminals energized at more than 300 volts, or with exposed parts energized at more than 50 volts, the employer shall ensure that the employee uses tools or gloves rated for the voltage. When an employee installs or removes expulsion-type fuses with one or both terminals energized at more than 300 volts, the employer shall ensure that the employee wears eye protection meeting the requirements of Subpart E of this part, uses a tool rated for the voltage, and is clear of the exhaust path of the fuse barrel. 1926.960 I. Covered, non-insulated, conductors. The requirements of this section that pertain to the hazards of exposed live parts also apply when an employee performs work in proximity to covered, non-insulated, wires. 1926.960 J. Non-current carrying metal parts. Non-current carrying metal parts of equipment or devices, such as transformer cases and circuit breaker housings, shall be treated as energized at the highest voltage to which these parts are exposed, unless the employer inspects the installation and determines that these parts are grounded before employees begin performing the work. 1926.960 K. Opening and closing circuits under load. 1926.960 K1. The employer shall ensure that devices used by employees to open circuits under load conditions are designed to interrupt the current involved. 1926.960 K2. The employer shall ensure that devices used by employees to close circuits under load conditions are designed to safely carry the current involved. Table V2 AC liveline work minimum approach distance. Table V2 AC liveline work minimum approach distance. Employers may use the minimum approach distances in Table V5. If the worksite is at an elevation of more than 900 meters, 3,000 feet, see footnote 1 to Table V5. Employers may use the minimum approach distances in Table V6, except that the employer may not use the minimum approach distances in Table V6 for face-to-face exposures if an insulated tool spans the gap or if any large conductive object is in the gap. If the worksite is at an elevation of more than 900 meters, 300 feet, see footnote 1 to Table V6. Employers may use the minimum approach distance in Table 7 through Table 14 in Appendix B to this subpart, which calculated MAD for various values of T, provided the employer follows the notes to those tables. Use the equations for face-to-ground exposures, with VPeak for face-to-face exposures, unless the employer can demonstrate that no insulated tool spans the gap and that no large conductive objects is in the gap. Until March 31, 2015, employers may use the minimum approach distances in Table 6 in Appendix B to this subpart. Table V3 electrical component of the minimum approach distance, D, in meters, at 5.1 to 72.5 kV. Table V4 altitude correction factor. Table V5 alternative minimum approach distances for voltages of 72.5 kV and less. Employers may use the minimum approach distances in this table provided the worksite is at an elevation of 900 meters, 3,000 feet, or less. If employees will be working at elevations greater than 900 meters, 3,000 feet, above mean sea level, the employer shall determine minimum approach distances by multiplying the distances in this table by the correction factor in Table V4 corresponding to the altitude of the work. For single-phase systems, use voltage to ground. Table V6 Alternative minimum approach distances for voltages of more than 72.5 kV. Employers may use the minimum approach distances in this table provided the worksite is at an elevation of 900 meters, 3,000 feet, or less. If employees will be working at elevations greater than 900 meters, 3,000 feet, above mean sea level, the employer shall determine minimum approach distances by multiplying the distances in this table by the correction factor in Table V4 corresponding to the altitude of the work. Employers may use the phase-to-phase minimum approach distances in this table provided that no insulated tool spans the gap and no large conductive object is in the gap. The clear live-line tool distance shall equal or exceed the values for the indicated voltage ranges. Table V7 DC live-line minimum approach distance, in meters, with overvoltage factor. The distances specified in this table are for air, bare hand, and live-line tool conditions. If employees will be working at elevations greater than 900 meters, 3,000 feet, above mean sea level, the employer shall determine minimum approach distances by multiplying the distances in this table by the correction factor in Table V4 corresponding to the altitude of the work. Table V8 assumed maximum PR unit transient overvoltage.